This video is going to illustrate how to use the Water Resources database to import field measured data into a form that can be used to compare WASP predicted values, what was measured in the stream. So we're going to talk about different ways of where you can get your observed data, how it needs to be organized to a form that can be readily accessible by WRDB Graph to compare with WASP model predicted data. We'll talk a little bit about pulling data from the Water Quality Data Portal, which is basically a website where you can access both US EPA STORET data and USGS NWIS data. We're going to actually process our observed data, for example, from a spreadsheet. As far as getting data ready to go into WRDB, there are some required fields for importing data. So the only way that you can import a valid data record into WRDB is you have to have a field that has station or a location string associated with it. You need the date time from when it was measured, and it could be in virtually any date time forms, whether it's month, day, year, hour, minute, second, all in separate columns versus one that's completely concatenated together. You'll need to have a parameter code that tells us what the measurement is, something like ammonia, nitrate, dissolved oxygen, and then you'll actually have to have the value that was measured. So that's the minimum data requirement for pulling data into WRDB. Now, as far as examples of obtaining data, the first one is the Water Quality Data Portal. It's a joint portal between the USGS and EPA. And you can download data based upon HUC or geographical area, and it'll create two zip files that contain station information and then data, measured values, which you would have to manipulate to bring into WRDB, but it would be a good start. What we're going to be doing today is we're actually going to be able to bring in data into WRDB, and we can bring it into a couple different ways. The easiest format is what I would call row format, where we have four columns: station ID, P code, date, time, and result. Remember, this is the minimum required data, and all of our data just goes in this row, and the station ID would just change as you went down the row. It's kind of hard to get your data in this format a lot of times because usually you're giving it to a station at a time. The other way we could bring data in is by columns, and that looks more like this, where you have a set of columns with parameter codes for each of the individual stations. And we'll look at how you can bring that data into WRDB as well. So with that, what I'm going to do now is I'm going to just give you a live demonstration of how to use WRDB to import data. I'm opening up the WRDB project that we created in the watershed example webinar that you can go back and review from the WASP website and bring us to this point. But to bring in observed data, we're going to be accessing data from a spreadsheet that will that contains data, and we, like I said, we can organize this in a couple of different ways. But the first way I told you was the row way, where we would have all of our data basically going down in 4 sets of columns, and we can bring this into WRDB a couple of different ways, and I'm going to show you a couple different ways. And then the other way is actually probably more what you're used to seeing is in a columnar format, that there's your station and there's your measured data and how we would get that into WRDB. So we'll look at and explore the various ways. So the first thing I'm going to do is I'm going to create a new working table for the observed data. So I'll hit Create New, and I'm going to type in the name of the table, and I'm just going to call this Row Wise Observed Data, just to see how it works. And then this is just example. So I'm going to close this, and I'm going to use a utility that's built into WRDB called DB Import. I'm going to invoke that by saying Edit, Import, Import Data. And I'm going to find my spreadsheet that's called Observed Data, and I'm going to click on the sheet that I want, and I want the row sheet. I'm going to click OK, and then this little utility pops up that basically allows you to map columns into specific fields in WRDB. Because I used the field names in my column headers, it automatically knew how to bring all of that data in. But if I had something else here called measurement, I could come up here and link it to the result field for that. So with that everything lined up, it's just going to read all of this information in. Now one of the things that did happen during this import is, hey, these stations did not exist in the support table under stations, so they were automatically added. So if I hit continue, it's going to let me bring all of that data in, so now it's here. If I open up the support table, we'll see that it added these stations. And a little bit later on in this video, I'll show you how we're going to edit to make these a little bit more useful. But they were automatically added. And if you actually had a P code that wasn't in the table already, it would have added that as well. So just to show you that that data is in here appropriately, let me just plot the water temperature for our Lake Sarah station. I'll be just hit on, well, let me go ahead and query out. I'm going to query out Lake Sarah, and I'm going to query out temperature. And then I'm just going to go ahead and plot it. So the data popped in there just fine. So that's one way to bring the data in. The next way is I'm going to go ahead and open up another working table, and I will call this one column-wise. Now to do this one, it's going to be done a little bit differently. I'm going to actually open up Excel itself with the spreadsheet in it. And I'm going to come over to the column tab. Now the thing is with this, I am going to have to bring it in a station at a time. I can't bring them all in at the same time because it has no way of parsing this out. So I'm just going to grab this first station, which is that LS01 Lake Sarah. I'm going to copy it. And another way that you could put it into WRDB is you could just go edit, paste imported records, and it brings the same thing up. Now you'll notice here that back in the spreadsheet I had the P codes up at the top, and they matched the P codes in my WRDB table. So WRDB already knew to line up that data with that particular P code. The only thing it really doesn't know is, I don't know what station this is associated with, and so this is Lake Sarah. So what we have to do is, and this station already has to exist in the support table to work. If it's not already there, you need to add it to the support table before coming here. But once I put it in here, once I set the station ID here, I can pull all of this data in, and I ended up with the same table as I had before. And if I run the same query, I will get the same graph. So that's pretty much how you get data in and out of it. You can either cut and paste it into WRDB, or you can import the use the import utility, which supports not only spreadsheets, comma separated value files, text files, Microsoft Access files. It's very, very powerful. If you can get your data organized in any fairly logical structure, you should have no problem importing it into WRDB. Okay, now we're going to discuss how you pair your observed data with model data and the things that you have to know before you start this process in WRDB Graph. First, you kind of need to know where everything is when it comes to location and space. So over here on the left is our model network that we used for the watershed, and you'll notice that we have 5 measured stations up here. So the first one is Ambrose River at Parkway Bridge. That's this one right here, and it is associated with WASP segment 10. The next one is AR2, which is down here, and it's associated with WASP segment 4. And then Wool Creek is over here, and it's associated with WASP segment 18. Martin River is over here, and it's associated with Martin River segment 22. And then our last one is the Lake Sarah monitoring station, which is out in the middle of our lake. So it's critical to know the station in WRDB and what segment in WASP it corresponds to, because this is information you're going to need when we do the graphics. The next thing is you need to be able to pair WRDB parameter codes or P codes to WASP output names. So in our case here, we're going to be pairing these parameter codes from the WRDB database to these output variables that come out of WASP. So this is pretty much verbatim how they work. Next, I'm just going to demonstrate using a WRDB graph to set up a calibration tool that we'll be able to use over and over and over again. Okay, I'm going to show you how to use the WRDB graph tool to plot observed versus predicted. I'm assuming that your watershed example, which is available from the EPA WASP.com website under the WASP course files for download. There's a folder there called watershed example. So with that, I'm going to load the WRDB graph program, and it's going to come up, and it's bringing in my watershed BMD2 file, which is the result file from WASP. And before I can even start using the calibration tool, I have to open up the other data source. In this case, I'm going to go to a WRDB project file, watershed, and I'm going to click on the row-wise observed data that we imported just a second ago. And that shows us the stations that are in there and then the parameter values that are there. So with these both loaded, what we're going to do now is we're going to pair up the information, just much like in the PowerPoint beforehand. So I'm going to click on the Build button, and I'm going to go Manage Calibration Datasets. I'm going to create a new pairing, and I'll just call this Calibration. And then I get a dialog box that looks like this. There's a couple of tabs here. There's Measured Data, Simulated Data. So on the Measured Data tab, I'm basically going to say I want to create a grouping using every one of these stations and every one of these P codes. And I'm going to build an aggregate list. So now I have stations over here, and I can actually change the names by using the rename function here if I want to, but this works out fine for right now. So these are the stations that I'm willing to pair up. So the next thing I need to do is click on the simulated data, and I have to pair up the station and the output variable. So if you remember from the table before, Ambrose 1 is right here. So I would click on that, and then BOD was total BOD, which is this one, and then chlorophyll is total chlorophyll. DIP is dissolved inorganic. DO is dissolved oxygen. That's ammonia. Nitrate. Temperature. Total nitrogen. And total phosphorus. So basically I said for AR1, for Ambrose River 1, for all of these parameters, I want you to use this segment information, and for each one of the parameters, the appropriate output control. So the next thing we need to do is we need to go on to AR2, which was segment 4, which is this one. LS1 is segment 1. MR1 is down here. And that one is right here, WC1. So now, because the variable names haven't changed, they're all hooked up. So now we've actually paired all of the stations in our WRDB observed database with WASP segments, and all of the parameters that we have measurements for in the database with WASP output. So that gets us to this point now. So some of the options that you have here are you can aggregate hourly, daily, weekly, and monthly, and it'll automatically aggregate the data for you. You can also control the percentile distributions that you want to do the 5th through the 95th, the 10th to the 90th, so on and so forth. We'll leave it at the 5th and the 95th right now. And another nice function is it's to interpolate simulated value pairs with the measured data. So basically when it's doing graphics and statistical calculations, what it'll do is for every measured value, it will go find a value from the model output. If there's not a model output at that specific time, the the WRDB graph will automatically interpolate one. So one of the first things we can look at is we can look at calibration statistics by himself. If we just click on that button, we get a dialog box that looks like this. We can pick the stations that we want. I'm going to pick all of them. And then I can pick the parameters what I want. And I'm going to again pick all of them. And I can ask it to do either a detailed or a summary. I'm going to just do a quick summary. And I'm going to click the refresh button. And what it's doing is it's going to the model output and the database, and it's coming up with information. So the table looks sort of like this. Here's our stations. Here's our parameters. Here's our measured data. Here's our simulated data. There's our R-squareds, our root screen error, so on and so forth. So it lets us do a quick comparison. Next, we can close out of this, and we have the ability to build calibration layout plots, which if we go to build and we go calibration tabs and layouts, I'm only going to pick one of these for right now because this does take a little bit of time, and we'll do it, well, let's do it for here. And we'll do it for chlorophyll for the lake. So it's going to generate this plot, a series of plots. The first one being observed versus predicted straight time series. The next one is a probability distribution plot that basically the blue line is the model predictions over throughout the simulation period in a probability distribution, and are the observed data. And then the last one is a scatter or one-to-one plot that basically shows the simulated line versus the measured line. So a perfect calibration would be the red line on top of the blue line. So that's one of the real nice features that you have here. WRDB also has the ability to send these plots to a file that you can put into reports. And if I just right mouse click on this thing on the graph anywhere, I can say send image to, and in this case I'm going to use the calibration option. If you don't have it, you can create one, and basically the way it works is you tell it how many different images you want. So I'm going to just say the setup. I'm going to say I want 2 rows and 2 columns, and then pick what you want to go in there. And it creates this file for you that looks like, it's a JPEG file that looks like this, that shows us the observed versus predicted and the probability and the one-to-one and the calibration statistics.